Okay, in our last lesson, we learned a lot about chords and when they're equal and when you could multiply their segments when they intersect. On this, we're going to talk about the external segments, secants and tangents, and doing some things with them. Basically, whether it's secants or a secant and a tangent, you're going to take the external part, which I like to call the nose because it kind of looks like a nose sitting out. You can see the red nose here. Times the whole. So the nose part, EA, times the whole part, EB, equals the nose part, EC, times the whole part, ED. So I just think that the products of the nose times the whole are equal. Now on this one here, EA is the nose, but it's also the whole. The whole thing on that tangent is a nose. So that's why it's EA squared. Sometimes I just think of it as EA times EA, but really that's the same thing. It's still the nose times the whole because the nose is EA, the whole thing is EA, equals the nose EC times the whole thing ED. So those are your theorems, and we'll go ahead and practice them together. Okay, so on this first one, the nose part is RP times the whole part is RQ. So the nose is 9 times the whole is 20. And that should be equal to the other one. The nose is 10 and the whole thing is 10 plus x. Don't be scared about having a 10 plus x there. You know how to use your distributive property. So that'll give you 100 plus 10x is equal to, I believe, 180. Subtract 100 from both sides. So I have 80 equals 10x. And then x is going to be equal to 8. Okay, you might want to try the next one on your own, but if you do, pause the video, and we'll go ahead and work through it now. If you have this, the nose is 4 times the whole is there, so that's going to be 4 times 2x plus 4. I usually write the x in front, but you could write 4 plus 2x, it's the same thing, equals the nose, which is 3, times the whole, which is all that together, so that would be 3 times 3x plus 4. And if you want to write 3 plus 3x plus 1, you could, but it would simplify to 3x plus 4. Okay, then I just need to distribute to get rid of those parentheses, so 8x plus 16 equals 9x plus 12. Need to subtract 8x from both sides. So x plus 12 is 16, and then subtract the 12, and it turns out that x is equal to 4. And once again, if they wanted you to, you could always plug the 4 in and figure out those segments, but usually they let you stop there.